In our previous video, we stated that 0 factorial somehow equaled 1. How is that even possible? Four factorial equals 4 times 3 times 2 times 1. 5 factorial equals 5 times 4 times 3 times 2 times 1, and so on and so forth. What does 0 factorial even mean, and how in the world is it equal to 1? If a number factorial is equal to itself times every integer counting down to 1, how in the world does 0 factorial even exist? It's less than 1. And moreover, how is it equal to 1? Let's find out. If we were to write out factorial algebraically, n factorial would equal n times n minus 1 times n minus 2 times n minus 3, on and on and on, all the way until we get to 1. Similarly, n minus 1 factorial would just equal n minus 1 times n minus 2 times n minus 3, on and on, all the way down to 1. Let's write n in terms of n minus 1 and see if we can solve for 0 factorial. Writing n minus 1 quantity factorial in terms of n factorial, if n minus 1 factorial equals n minus 1 times n minus 2 times n minus 3 going all the way down to 1, and n factorial equals n times n minus 1 times n minus 2 times n minus 3 going all the way down to 1, well then n factorial equals n times n minus 1 quantity factorial. This whole quantity is simply n minus 1 quantity factorial. So I can just write n factorial equals n times n minus 1 quantity factorial. Rearranging terms, we have n minus 1 quantity factorial equals n factorial over n. Let n equal 1. Then 1 minus 1 quantity factorial equals 0 factorial, which equals 1 factorial over 1, which equals 1. 0 factorial equals 1. Now, this has been a lot of fun. In an ideal world, we'd be sitting under trees all day, feeding each other fruit. Fortunately, on the GRE and GMAT, you will not need to use 0 factorial, but it is very interesting regardless that it equals 1. Thank you very much for joining us, and we'll see you in the next video.